JDBC is an acronym for Java Database Connectivity, which is a vendor-independent Java API for connecting to a database. It allows a Java program to communicate with a database using SQL commands. The JDBC API provides a vendor-neutral mechanism via standard interfaces that are actually implemented by third parties such as MySQL, Oracle, etc. A typical Java application simply uses the JDBC interface variables to either connect or execute SQL commands or manage transactions, etc. But at the runtime, these interface variables refer to instances of some classes provided by third-party or DB vendors to us. The process of creating instances of the implementing classes is completely transparent to our program. This method allows us to easily switch between any databases by simply changing the JDBC connection information. This way, our application is very loosely coupled with the underlying RDBMS itself. The only information that changes from one DB to another DB is a database driver class name, a connection string, we call it as URL, a username and password to the actual database. The key player in a JDBC application is the driver class. So the very first thing that you may have to do in any application in order to work with JDBC is to load the driver class into the Java virtual machine. There are 4 types of JDBC drivers that exist, out of which only the last one is in use today. The type 1 drivers are also known as JDBC ODBC bridge. These drivers are not in practical use anymore. In the earlier days of Java, most of the databases were accessed using the ODBC drivers. The ODBC drivers are written in C or C++, and a suitable database client driver must be installed in order to work with this ODBC driver. The way JDBC ODBC bridge works is you first register DB-specific ODBC client driver with the operating system, and there will be a name associated with this. And in your Java application, you will load a JDBC ODBC driver, and then you will say that we want to connect to that specific ODBC driver with the name. Then your application communicates to the ODBC driver, and then the ODBC driver talks to the underlying database. For practicality issues and performance problems, these are not used anymore. The type 2 driver is also known as partial Java driver. In this, the JDBC method calls would be converted into native C or C++ calls, which vary from one database to another. These native APIs are part of the DBMS software that you are working with. For example, if you're working with Oracle, you must install the Oracle client driver on your computer, and then your Java application communicates with that one. The drawback of this approach is on every of the computers where Java client applications being executed, we have to install the native client APIs as well. This is a huge overhead when the number of clients are more. In the olden days, Java applications were typically installed on hundreds of client machines, and you may have to install the DB client driver on each one of them. So this type of drivers were in use during the early days of Java, where the industry used 2-tier architectures predominantly. Type 3 drivers are also known as pure Java drivers for database middleware. In the early days of multi-tiered architecture for applications, some of the database vendors provided a pure Java JDBC driver that communicates to a middleware server on which either ODBC or native client driver would have been installed. The driver on the middleware further communicates with the actual RDBMS. The huge advantage of this approach is that there is no need of any setup to be done on the client machine itself, which allows us to increase the number of clients drastically. On the downside, we have to set up a middleware server. Type 4 is the most efficient and the most commonly used one. This is also known as pure Java driver. This driver, usually provided by the database vendor, directly communicates with the RDBMS using Java sockets. By far, this is the best performing driver compared to all other types of drivers.